Hello everybody. I'm Vladimir Kolyukin. I'm with Utah State, a research professor over there. So it's good to be back at the institution where I spent a good chunk of my sabbatical in 2010. Just want to say hi to the people that know me and whom I know. I also want to say hi for Bill Crandall, one of my mentors. Bill has Parkinson's. He couldn't be here, unfortunately, but I had a Skype conversation with him. He's in Georgia, so he says hello as well. Okay, so the title of my talk, well, I guess it's in line with, I definitely want to know about secret sauce, so that I just want to, so it's vision-based nutrition information extraction from product packages on smartphones. And I just want to qualify this by saying that this is one of the projects that I started working on about a year ago, and the low vision and visually impaired individuals were not the focus of that project. So it's, I got some private funding from industry, and there's a company, Utah-based company, MDSC. It does a lot of work for the Utah Department of Health. And about 11 months ago, I got a phone call from them, and they said, Vladimir, we understand that you've been doing some grocery shopping apps. And I said, well, yes, primarily barcode-based, though. And well, that's okay. We need a vision front end for our nutrition management system. And it turns out that they are developing a system for the program called BeWise, and this is a program for women who have been diagnosed with breast cancer. There's about 100 active outdoor patients, and they want to manage, help them manage their nutrition for them. And so what a good chunk of what I will be talking about has low vision and blindness as an added value. So Mike May, I don't know where Mike is, but what he said reminded me of his talk at the World Blight Congress in 2004, where he said that, well, low vision accessibility can only be an added value in a commercial software development, which is very true. Okay, so I will motivate my top critical barriers. Then I will tell you how I got from robotic shopping carts to Peanuts. Peanuts is an abbreviation of the system. It stands for Persuasive Nutrition Management, Nutrition System. And then the gist of my talk is what information can be reliably extracted from product packages and how. I will tell you how dogs can eat skewed barcodes, and how lines and corners can text chunk nutrition labels. And I'll spend a minute on preliminary results and conclusions. So the motivation is that U.S. Department of Agriculture estimates that the U.S. residents have increased their caloric intake by 523 calories per day since 1970. Mismanaged diets are estimated to account for 30 to 35% of cancer and diabetes cases. Well, I'm not sure about cancer, but I have a very close familiarity with diabetes. My father died of diabetes. My younger brother was just diagnosed with diabetes. So it's a killer disease. So many nutritionists consider proactive nutrition management to be a key factor in controlling cancer and diabetes. And obviously, this is the added value. Nutrition information needs to be available to low vision and blind individuals. So now, what are some critical barriers? So there are primarily three, and that is a lack of automated real-time nutrition information analysis. Barcodes, especially skewed ones, and nutrition labels have a lot of characteristics that impede timely detection or adequate comprehension, well, especially nutrition labels. Then lack of automated real-time context-sensitive nutrition decision support. Right now, we have very weak coupling of purchasing decisions to patients' current locations, ODLs. ODLs stand for Observation of Daily Livings and Public Health Records. And then lack of automated real-time nutrition intake recording. So manual nutrition intake, that is sort of the state-of-the-art in nutrition management systems, is very time-consuming and error-prone, especially on smartphones, as most of you know. So, so this is my road to from robotic shopping carts to Peanuts. So that's a big robot. Used to cost us $15,000 that I started thinking about in year 2000, and implemented my graduate students, and I implemented it. And then it sort of was getting smaller and smaller ever since, and now it's all just one Android phone, right? And that Android phone has more processing power than that robot. So that's just how far we have come. And by the way, persuasive, I borrowed that term from Dr. Fogg. He's he's a cognitive psychologist from Stanford, I believe. And he has this nice framework called persuasive technology. So anyway, what information can be reliably extracted from product packages, and how? Well, on product packages, there are two types of information. There's skewed, barcodes. Well, skewed, I would add. And then nutrition fact tables. So there's a lot of work that has been done on barcode scanning, assuming that you can align the camera. But for low vision individuals and people, elderly individuals who have, let's say, Parkinson's, right, hands shaking. So it's nice to just take a picture of the surface where barcode is positioned somewhere and being able to scan it. And then the same thing with nutrition facts. As a matter of fact, if we can do barcode scanning, barcode localization and scanning, and nutrition nutrition label reading, then we can essentially construct our own databases, automate the construction of our own databases. So, so this is the current state of the system, and that is you can take a frame of a skewed barcode, and if it's anywhere in the picture, it will be localized. And then also nutrition label, it will be localized and chunked. Now, I want to say right now that I did not want to work on OCR. So for OCR, I have been using Tesseract. Okay, so once the text has been chunked, then it is fed to the Tesseract, runs in the cloud, and then it's as good as Tesseract. Okay, so now how do we detect skewed barcodes? I mean, it's one of the technical, for those of you who have been working on barcode localization and scanning. Localization is a much harder problem, right, than scanning the barcode, right? Especially if you cannot assume aligning. So, what I do in this system is develop this dominant orientation of gradient that you can push a mask of a specific size, like 20 by 20, is what I do. And then you can compute the average gradient orientation in that mask, right? And then it turns out that the parts of the image that have similar gradients can be combined into bigger clusters, also using some geometric constraints. And then you can have a nice barcode localization area. And then since you know the gradient orientation, you can take a line and just send it to some barcode scanning algorithm, such as zebra crossing or something that Endertech has developed here. So, but it's generally considered in the community to be a solved problem. Once you have a pixel-wide line that covers the entire barcode, then it can be reasonably solved. Localizing it is what the problem is. And for the text spotting, well, you can, if you take a look at the nutrition label, you can detect a lot of nice lines. And then also, you can use the dilate and erode corner detection. And the hypothesis here is that chunks of text will exhibit a larger than normal concentration of corners. And then you can use both of those things to extract text, and then feed it into into an OCR engine. So, okay, and that's essentially how the system works right now. Again, I have not implemented OCR, so I want to make sure that I'm not solving the OCR problem. So as far as the barcode, the skewed barcode localization, I believe that we have, we have a good solution, skewed barcode localization. So tested it on 1,000, like over 1,000 images, well, frames actually extracted from real videos, UPC barcodes, and it localizes the barcode pretty well. I'm surprised that the zebra crossing did not perform as well as I expected it to perform on scanned barcode lines, because the idea is that you should avoid rotating the image. You know, you can just take a scan line and then feed it into the scanner. And then for the nutrition localization, I have so far been able to, well, for this talk anyway, the experiments are ongoing to test it on 45 images. And the problem was that I needed to manually identify the frame in each, the nutrition table in each frame, so that to get some ground truth, right, of how well I can localize and text chunk. And then this is all done on Android 2.3.6 and 4.2. I'm not gonna get into the discussion, as David Ross, right, wants me to engage what's the relative advantages and disadvantages of iPhone and Android. I actually believe that, I mean, it depends on your perspective. So if you're open source, Android. If not, if you want to make money, then obviously iPhone. But it's all going to get irrelevant anyway with cloud computing. I believe that HTML5, right, and similar developments will essentially turn the cell phones into just gateways into cloud computing services. So he who controls the cloud controls the world, right? So I mean, and it's either you eat into your data plan or into your battery life. I mean, that's life. Yeah, okay, I'm almost done, James. So anyway, so the dog performance on the sample of those images, precision was 90%, true negatives 97. It's a very conservative algorithm, but the good thing is that it doesn't hallucinate. False positive is only 2.5%. And then the nutrition label localization performance was, a mean error was about 1%. And then we also estimated text chunking, but that's the work in that's work in progress. So we hope to improve it. And then, you know, well, I estimated the relative advantages and evaluated the relative advantages and disadvantages of GOCR and Tesseract. Tesseract appears to be better than GOCR, although GOCR appears to be a little bit faster. But what I like about them is that they both open source, and I can tinker with the C code. So and that's always good. Anyway, so these are some references that are documenting the details, technical details. I would, you know, it's not a pitch. It's like basically, I don't want to pitch my blog, but the most useful, if you're a techie, is the last one, because I run a very active technical blog. And most of the low-level C, like programmatic issues, are addressed at that blog. I mean, the papers are, I mean, I guess they're read by 10 people, 3 reviewers included, and there's sort of it's what you do to maintain your current salary and get salary raises at your research universities. So, but that's the. Anyway, okay, well, thank you, and I'd be happy to take questions, if there are any.
Thank you. Questions? No questions from the audience?
Yeah.
Well, I was just going to ask, I know you've done a lot of work with testing some of your barcode apps with blind users. Can you just say a few words about that? That was not the emphasis of this talk.
Right, right. Well, I mean, we have, I'm not gonna, well, I don't want to pitch it too much, James, but I think that as far as barcode localization, like real-time barcode localization is concerned, that problem, for all practical purposes, well, can be considered closed. Okay, so because like there's a good understanding of how that is done. Scanning skewed barcodes, I mean, zebra crossing is supposed to be a state of the art, right? And it turns out that it has a lot of problems reading the skewed barcode lines. I mean, if you align, then it works really well, but skewed. So if like there's an intern somewhere, right, or an undergraduate who wants to address that problem of skewed barcode scanning, that would be a good scanning, not localization, right? So yeah, I mean, and yeah, it works. So yeah.
Oh, okay.
Yeah.
Gordon?
So just to clarify, if you identify the barcode, is it plausible simply to capture the nutrition or medical information online and skip the OCR part of the analysis?
It depends, right, Gordon. It's as good as your nutrition databases. So that's, if you have access to, let's say, the inventory control system of Walmart, then yes, so long as you can capture a barcode, then the nutrition information theoretically is available. The problem is that I have been trying to work with Walmart for 3 years. They turned me down. So they, and then even the local supermarket, you know, they do not want to give you access to their inventory control system. So.
One more?
But yes, the answer to your question is yes. I mean, theoretically, if you can spot that.
Another question? Oh, Christopher. Getting my exercise.
Yeah. So you keep saying skewed barcodes. You actually showed an misoriented barcode.
Well, that's what I mean by skewed.
And
yes.
so skew is a more extreme
That's right.
distortion, and
That's
perspective is even more extreme.
Yes.
So can you handle perspective?
You mean like warping, right? Does that, like okay,
So
no.
the lines are no longer parallel.
The answer is no. No.
So it's just rotated.
No, I was just giving him a hand signal. What we meant by skew.
Right. That's what I guess James was gracious enough to allow me to talk about that, but I forgot to mention in the grocery store experiments with low vision individuals, we're actually trying to use the internal sensors of the Android phone to help keep the camera aligned with the surface. And that's what, so the barcode can be skewed, but the camera will be aligned in the pitch and yaw plane with the barcode surface. So, yeah, I didn't mention that.
It's really not solved at all.
Okay. If there are no other questions, let's thank Vladimir again.